converting one program into another form and displaying the result to the user. That antivirus software is mainly used to perform some specific kind of tasks. We know that assemblers are the translator that is mainly used to translate one type of program into another type of program. Translation is based on line by line. So errors are shown line by line. Hello to all, a warm welcome to my new session. I am Revati, faculty, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU. We are on the 7th session of computer software. Moving further, in today's session, I'm going to deal with operating system, utility programs, then I'm going to deal with programming languages, then I'm going to deal with assembler, compilers, then I'm going to deal with interpreter. So before going to start today's session, let me to recall the things what I discussed in my last session. In my last session, I discussed what is real number and how to represent real numbers in computer system. So the real numbers are represented by using fixed point and floating point notation. At the same time, we studied what is computer software and the type of computer software. But in today's session, I'm going to deal with operating system, utility programs, and programming language, assembler, compilers, and interpreter. In today's session, I'm going to deal with operating system. So what is operating system? Here operating system is example for system software. I repeat, it is example for system software. Here operating system is a set of program. I repeat, it is a set of program or instruction which act as interface between the user and computer system. That means here operating system provides the platform for user to execute their program or user to work on the computer system. So here an operating system is a set of instruction or program which act as an interface between the computer and the user. So here the operating system provides the platform for user to work on computer system. So the main system software is the operating system. That means the example for system software here is operating system which start up the computer and controls its operation. That means here the operating system is responsible for starting your computer system and it is also responsible for controlling your operating system. So the system software, that is example for system software, here it is operating system. So it is responsible for starting on your computer system and it is going to remain until you're going to turn off your computer system. So here the operating system manages all the resources, like it is responsible for managing memory management, resource management, process management, device management. These are the some of the functionalities of operating system. So here operating system manages the resources, resolves conflict and tries to optimize the performance of the system. So the operating system is responsible for resource management, resolves conflict. At the same time, it is also responsible for optimization of the performance of the system. The user communicate with the computer through operating system commands and program instruction. That means here The user is responsible for operating or communicating with the operating system based on by some commands or by using some program instruction. So operating system plays very important role in computer system. So without operating system, the computer system is dummy. So first, what we want to do, we want to install the operating system. Then only it is possible to work on your computer systems. So here it acts as an interface or mediator between the user and the computer. And the main job of operating system is to provide the interface. At the same time, it is also responsibilities of operating system here is it provides services to the application software. It is also responsible for providing or establishing interface between user and computer, and it is also responsible for managing all the resources like hardware, CPU, memory management, device management, etc. So in operating system, the user can capable to communicate with the computer system by using some of operating system commands and the program instruction. So here the operating system plays an important role for loading programs from disk into memory, displaying message, translating program, and in outputting the result. That means here the operating system plays a major role. That means it is responsible for loading program from memory to disk or disk to memory and displaying the message or output to the user and translating program. That means converting one program into another form and displaying the result to the user. These are the some of the important role of operating system. Then the best examples for operating system is Linux operating system, Unix operating system, then MS DOS, then Microsoft Windows. In Microsoft Windows, it may be Windows 7, Windows 10, Windows XP, etc. These are the example for operating system. So by seeing this figure, we can able to tell a operating system is a mediator or interface between user and the computer hardware. Suppose the user want to communicate with the computer system. So the user is going to communicate with the operating system. So here operating system provides the mediator or interface between hardware, then memory, then input output devices. That means here operating system act as an intermediator for hardware and the computer user. Moving further, we are going to get utility program. So here utility program or utility software is a software that is mainly used to perform some specific kind of task. So here the specific kind of task may be virus protection or file protection or scanning or cleaning virus or password protection or file management. These are the some of the functions of utility program. So it is a small and helpful program. That is, it is nothing but a set of instruction once again, but it is designed to perform some specific task. So here what kind of specific task? That is virus protection, or if you want to protect your file, or if you want to clean up your disk, or if you want to take backup of your disk. These are the some of the specific tasks performed by the utility program or software. So here utilities are those helpful programs that assist the computer by performing helpful functions like backing up disk, scanning or cleaning virus, etc. So here utility software is generally called as application oriented ready-made system program. I repeat, it is also called application oriented ready-made system program. So the example for utility softwares are text editor, backup utilities, disk defragment, antivirus software. These are the certain software comes under utility software. So consider the antivirus software. That antivirus software is mainly used to perform some specific kind of task. So what kind of task it is? Protect your data or protect your information from the virus. So the job of the antivirus here is protect your data or protect your computer system. Then text editor, that is mainly used to perform some specific task. What kind of task here? That is mainly used to create text, or it is mainly used to alter text, or it is mainly used to maintain the text. So here utility software is a program or set of instruction that is mainly used to manage, analyze and control the system. So moving further, we are going to study programming languages. So what is programming language? Here programming language is a media or medium of communication, or it is a way of communication. It is a computer language and it is used to communicate with the computer system. I repeat, a language is nothing but a way or medium used to communicate, whereas computer programming language is a language that is mainly used to communicate with the computer system. So here such languages are called programming language or computer language. Here using programming language, user can capable to instruct the computer what it should do. That means it allows the user to write the program. So that program is used by the computer system to instruct. That means what are the things the computer is capable to do. So here programming language plays very important role in computer system. Whatever the instruction want to give, that is written by using programming language. So the programming languages are classified into two types: high level programming language and low level programming language. Whatever the instruction we want to provide, that is written by using any one of these programming language. So here the programming language is a set of rules called syntax. That means to write program, we must have certain rules. We must want to follow certain rules. So here programming language is a set of rules called syntax which the user has to follow. That means user can able to write the program by using those syntax and to instruct the computer what operations are to be performed. So here the programming language is nothing but a set of rules called syntax which the user has to follow and instruct the computer what operations are to be performed. So here the programming languages are nothing but a set of rules or instructions. The user want to follow those set of instructions or rules to write the program, and that program is used to instruct the computer system what to do and what are the things it's not able to perform. Moving further, in language translator, we are going to get four different types of language translators, that is assembler, then we have compiler, then we have interpreter, then we have linker, and then we have loader. So these are the four different types of language translator. Moving further, assembler. So what is assembler? The assembler is a system software. That means the type of system software here it is assembler. So here assembler is a system software which is responsible for translating assembly level program into its machine language. That means we know that assemblers are the translator that is mainly used to translate one type of program into another type of program. So here the programs are written by using assembly level language that is translated into machine language. That means the job of the assembler is to translate assembly level language into its machine equivalent. It recognizes the mnemonics used in the assembly level languages and substitute the required machine code for each instruction. That means here assembly level programs are also called mnemonics. That means whatever the instruction is written by using assembly level programs are called mnemonics, and it is used in the assembly level language and substitute the required machine code into each instruction. So the example for assembler is Turbo Assembler, Microsoft Assembler. These are some of the examples for assembler. So here assembler is nothing but a translator. So what is the input? That is, the input is your source program. So what type of source program? It is mnemonics or assembly level language programs are the input to the assembler, and the output is machine code. So here machine code is nothing but zeros and ones. So here assembler is a translator that accepts assembly level language as its input, then it's going to translate the assembly level language into machine equivalent language. Some of the examples for assemblers are MASEM and TASEM. Moving further, we are going to study compiler. So a compiler is a system software. That means the example for your system software is compiler. So the compiler is a system software that translates the high level programming language into machine level language. That is, so it's going to translate source code into machine code or object code. So what's the input here? The source code is your input, and source codes are written by using high level programming language. And what is the output? That is machine language output, that is machine readable output. So here it is object code or machine code. It reads the whole program. That means the compiler is responsible for reading whole program and translate the entire program at once into a series of machine level language instruction. So in compiler, it's going to compile the entire program together. That means it's going to compile whole program once, and it is going to produce the output, that is machine level language instruction. So once compiled, the program normally gets saved automatically and it is executed directly. Example C and C++. That means once the compilation is over, then the programs are automatically saved and it is executed directly. So example here is C or C++. Consider your C program. What is the first step? You're going to write all the programs and you're going to save your program. So then what's the next step? That is, you're going to compile your program. So here your C program is example for high level language program. So all the instructions are written in C is in the form of high level language program. Then what is the output? That means what is the output from your compiler? That is machine understandable code, that is machine code or object code. So consider the example here, the source code, that is input to your compiler is your high level programming language. Then what is the output of your compiler? That is machine code, that is nothing but your binary code, that is zeros and ones. So here in compiler all the programs are compiled once. That means all the lines are compiled once and it is stored automatically and executed. So here the best example for system software is compiler. Moving further, we are going to get interpreter. So what is interpreter? The name itself indicates that interpret to line by line. That interpret means what? It is line by line execution. So it is going to execute one line at a time. So an interpreter reads once a statement of a high level language program at a time and translate it into machine level language and executes it intermediately. So an interpreter reads a statement of the high level language program at a time. That means it is going to read a statement once in a time and it is going to translate it into machine level language and executes its intermediate. So it continues to read and translate and execute the statement one by one until it reaches the end of the program. So the name itself indicates that it is going to read one statement at a time and execute. So this process is going to continue until it reaches the end of the file. So the execution of interpreter is very slow compared to compiler. So here interpreter is also example for system software. Moving further, let's see the difference between compiler and interpreter. So the compiler converts the source code written by programmer to a machine level language. I repeat, the compiler is responsible for converting source code written by the programmer into machine language. That means the compiler is going to convert the source code, that is high level language, into machine level language. Whereas the assembler converts the assembly level language into machine code. So what is the input for your compiler? That is high level programming language and the output is machine level language. Whereas for your assembler, what is the input? That is assembly level language and what is the output? It is machine code. Then compiler input source code. That means compiler is going to input source code. Here the assembler's input is your assembly level language. Then it converts the whole code into machine language at a time. That means in compiler it is going to convert. That means it is going to translate the entire or whole code into machine language at a time, whereas in assembler it is not possible to convert whole code. Then the next difference here is compiler is more intelligent than assembler, whereas the assemblers are less intelligent than compiler. So in completing compilation phase, it includes certain compilation phases are lexical analyzer, syntax analyzer, then semantic analyzer, intermediate code generator, code optimizer, and error handler. That means we know that in compiler is responsible for translating whole code into machine language at a time. So this is done by using these phases like lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, etc. Whereas in assembler makes two phases over the given input, that is first phase and second phase. In assembler we are going to get two phases, that is assembler 1 and assembler 2. That means it is going to use two phase to translate its input into the output. So the output of the compiler is a mnemonic version of machine code. I repeat, the output of your compiler is the mnemonic version of your machine code, whereas the output of the assembler is binary code. Then the example for compilers are, that is C, C++, Java are the examples of compiled language. That means all the programs are written by using high-level programming languages like C, C++, Java, etc. Whereas in the assembler we have TASM and MASM. So these are the some of the difference between compiler and assembler. Moving further, we are going to get the difference between compiler and interpreter. So we know that we have three different language translator, that is assembler, then compiler, then interpreter. Now we are going to discuss the difference between compiler and interpreter. So in compiler, it scans the whole program in one go. That means it is going to translate whole program into machine code at a time. Whereas in interpreter, it is going to translate one statement at a time. That means it is going to translate one line at a time. The next difference here is, here it scans this code in one go. The errors are shown at the end together. That means in compiler, the whole program or whole code is translated at a time and the errors are shown at the end together. But whereas in interpreter, we are going to translate one line at a time. So errors are shown line by line. That means here the translation is based on line by line. So errors are shown line by line. Then the next difference here is, the main advantages of compiler is execution time. So the compiler is going to have high execution speed, so comparing to interpreter. Whereas in interpreter, the execution speed is very slow. The execution speed of the interpreter is very slow. So in compiler, it converts source code into object code. I repeat, it converts source code into object code, where it does not convert source code into object code. Instead, it scans its line by line. So in interpreter, it is not going to convert the program, that is source code, into object code. Instead of that, it is going to scan its line one by one. In compiler, it does not require source code for later execution. I repeat, in compiler, it does not require source code for later execution, but in interpreter, the source code is required for later execution. Then the example for compilers are C++, C#, C, etc. Whereas interpreter, that is Python, Ruby, Perl. These are the some of the examples for your interpreter. These are the some of the difference between compiler and interpreter. Moving further, we are going to get linker and loader. So what is the job of linker and what is the job of the loader? So here, a source program written in high language may contain a number of modules and segments. That means a source program or program is written by using any high level languages like C, C++ or C#, may contain number of modules. That means number of subprograms. Then to execute properly, the modules are linked so that execution of the program is sequential. So we know that in high level languages like C or C++, it's possible to write the problem or program in many modules. So at the end, what we will do? We are going to combine those modules together to perform or to execute sequentially. So this operation is performed by the software called linker. So what is the job of the linker? Is mainly used to link the module or mainly used to link the program. So here the main job of the linker is to link the program or module. Consider the example. I have two modules in C program. This is main 1.c and this is my another module called C. So in main.c, I have added add.c. So during the execution of the program, it's the responsibility of the compiler is to get the code which is written inside the add.c. So the job of the linker is to link these two programs together. So here a linker is a software and it is the job is to link two different modules. So here the linker is going to take the object files which is generated by the assembler or compiler and link all the object files together. So the job of the linker here is it is going to take the object code which is generated by the assembler or compiler and combine those object code together. That means it is going to link those object code together to form executable file. So here linker is a system software that links means what? It is going to combine smaller programs to form a single program. So here the linker job is to combine or link the smaller program into form a single large program. So here a linker is a system software and that is responsible for combining many small program into form a single program. So the job of the linker is to link many small program to form one single large program. So then what is the job of the loader? The job of the loader is to load the program to the main memory. We know that all the programs are stored in computer secondary memory. Before going to execute, all the program or instruction which is stored in the computer secondary memory must be brought into the main memory. So that is the job of the loader. So the executable programs are stored in secondary memory that must be loaded into the main memory so that the computer can capable to execute. This operation is performed by the software called loader. So a loader is a system software that loads machine code of a program into system memory and prefer these program for execution. That means the job of the loader is to load the program to the main memory. So that is the main job of the loader. So let's see the difference between linker and loader. The first difference here is the main function of linker is to generate executable files. That means the linker is going to link or it's going to generate executable files, whereas the loader is to load executable files to the memory. I repeat, the job of the loader is to load the executable files to the main memory. Then the linker takes input of object code that is generated by the compiler or assembler. What is the input for your linker? That is the object code which is generated by the compiler and the assemblers or the input for the linker. Then the loader takes input of the executable files generated by the linker. That means what is the input for the loader? The output which is generated by the linker is the input for the loader. Then the linker can be defined as process of combining various pieces of codes and source code into obtain executable code. That means a linker is a software that is mainly used to combine or club many pieces of codes and source code into obtain executable code, whereas the loader is defined as process of loading executable codes into main memory for further process. I repeat, the loader is responsible for loading the executable code into the main memory for further process. Under linker, there are two types of linker, that is linkage editor and dynamic linker. Whereas under loader, loaders are four types, that is absolute loader, relocating loader, direct linking loader and bootstrap loader. These are some of the examples for loader. Then The links or combines object module. That means the job of the linker is to combine or join all the object modules, whereas the loader, it helps in allocating the address to executable codes or files. That means the job of the loader is to allocating the address to the executable codes or files. The next difference, linker is responsible for arranging objects in program's address space. I repeat, the linkers are responsible for arranging objects in program's address space. Here loader is responsible for adjusting references which are used within the program. These are the some of the difference between linker and loader. In my next session, I'm going to deal with types of programming language. In types of programming language, we are going to study machine level language, then we are going to study assembly level language and high level and low level programming language. These are the some of the types of programming language, and we are going to study these types of language in my next session. Dear students, in my today's session, you got more information about type of software. Thank you for watching my session. Let's meet in the next session. Until then, take care. Thank you.